Hello everyone. Today we're going to learn about Beer-Lambert's law. A quick review of some information that we've covered about solutions. Solutions are homogeneous mixtures where a solute dissolves into a solvent. The concentration of a solution is a measurement of how much solute is dissolved in a given amount of solution. For example, the more solute is dissolved, the higher the concentration will be. There are many possible units you could use for concentration. The two that are most common are molarity, which is a measure of moles per liter, or percent concentration, which is a measure of the mass per mass of solution. Some solutions will have a color to them while others will be clear. Generally speaking, solutions absorb light from certain parts of the electromagnetic radiation spectrum. Clear solutions absorb light in non-visible parts of the electromagnetic radiation spectrum, such as the UV or infrared regions. Because they do not absorb any light that is visible to us, they appear to be all colors, which means they are white or clear to us. Colored solutions, however, absorb a piece or multiple pieces from the visible part of the light spectrum. Generally speaking, the color of a solution will depend on the wavelengths that are allowed to pass through it, which means the color of the solution actually best reflects what is not absorbed by the solution. For example, if a solution is red, this means it allows red light to pass through it readily and does not absorb much red, but it will absorb colors that are from other parts of the spectrum. Generally speaking, the greatest absorbance for a colored solution will be the color that is opposite it on the color wheel. So consider for a moment, if you had a purple solution, based on the color wheel shown here, what color of light would it be most likely to actually absorb? Since yellow is opposite purple on the color wheel, this purple solution most likely absorbs in the yellow region. It might also have high absorbance in colors that are neighboring yellow, such as green or orange. Absorbance and concentration are related to each other. Consider, if you looked at a solution of Kool-Aid and you knew that it was dilute, how did you know that it was dilute just solely based on its appearance? Generally speaking, you would look at the color and how vibrant the color is. If it was very pale, this would imply that there's not very much of the solute in there. And because it's very pale in color, that also means it's probably not absorbing much light. So, absorbance for a solution is directly proportional to its concentration. The more solute there is, and the higher the concentration is, the more light will be absorbed and the darker the solution will appear to our eyes. The formula for this relationship is given by what is known as Beer-Lambert's law, or more simply, Beer's law. The formula for this is capital A equals ABC. We will now go over what these variables are. Capital A stands for absorbance, which is how much light is being absorbed. Absorbance does not have units and therefore is assigned arbitrary units, capital A, capital U, if you are including units. The lowercase a is something called molar absorptivity. This variable varies from solution to solution and also varies from wavelength to wavelength. It is occasionally also represented by the letter epsilon, although the lowercase a is more common. The units for this are generally per molar per centimeter, or molar inverse times centimeters inverse. B stands for the path length, literally how much of the solution do you have to go through. For example, if the solution was contained within a container that was 1 centimeter in width, then the path length would be 1 centimeter. C stands for concentration. For Beer's law, it is traditional that we use molarity for the concentration unit here rather than any of the other concentration units. So, as we will cover in class soon or have already covered, the concentration of several solutions can be used together to create a dilution series. And we can use the concentrations of a dilution series to obtain information about how absorbance and concentration vary for a particular solution at a particular wavelength. If this information is known, you could determine the concentration of an unknown solution as long as you knew its absorbance, because concentration and absorbance are directly proportional. We will now talk through how you might do this. So let's look at how we would determine the concentration of an unknown solution. We'll first do this by generating a Beer-Lambert plot, or a plot that plots absorbance versus concentration. First, we will need to collect information about absorbance and concentration for several known solutions. For example, you could use a dilution series, like we will talk about in class, as your known solutions. This should be a scatter plot, since we're trying to see if there is a linear relationship. We will plot the absorbance and concentration data that we collect. Then, from our scatter plot, we will obtain a formula for the line of best fit. It should generally take the form of A equals ABC. This means if you have the option to set your y-intercept to 0, this would be the most ideal for you to do, although not all programs allow you to do this. For this graph, A, the absorbance, is on the y-axis, while concentration, C, is on the x-axis. Therefore, the product of A and B, the molar absorptivity, and the path length, is what the slope is representing here. We are generally trying to initially find the slope because we have concentrations and absorbance. Then, if we want to determine something about an unknown, we would need to gather its absorbance. We would now then have the absorbance, and also we would know the product of A and B, molar absorptivity and path length, because we found it from our Beer-Lambert plot. Which means, finally, if I wanted to determine the concentration of unknown, I can use that line of best fits equation, plug in for absorbance, and solve for concentration. A reminder that on this graph, concentration is x, and so you will be solving that algebra equation for x rather than for y like you often do. There is a practice worksheet that is available that has you practice making graphs in Google Sheets and working with the line of best fit for a Beer-Lambert plot. This assignment is 100% optional, but is good practice for you. There will be a lab upcoming where this skill will also be practiced. Good luck!